All right, guys, this is pre-calculus 3.1.2, and we're going to be talking about rewriting expressions and equations today. So, oops, there we go. All right, so to start off, we're going to take a look at problem 20 here. So this is really, really nasty because we have fractions inside of fractions. Right? It's fraction inception. So the easiest way to kind of deal with fractions is we can get rid of them, right? So if I want to do that, what I'm actually going to do here is I would multiply this by x plus 2 over x plus 2. Now what that causes to have happen is when I distribute the x plus 2 into both terms on top, it'll cancel out here and I'll just get 7. So I'll have 7 plus 3 times x plus 2. And on the bottom, I'll have 8 times x plus 2 minus x. So again, it's not crazy better, but at least I have less fractions to work with. And then at that point, I can go through and try and simplify and reduce things out. Okay, so that's the big thing that we're looking at today is, hey, how can we take ugly, nasty things, make them look better so that they're easier for us to work with. And that is one of the biggest strategies which we want to learn, because fractions, especially really complex fractions, really freak people out. So if we can say, well, how can I deal with those? There's one way. The only thing you want to keep in mind is us doing that made it so that -2 is no longer an obvious answer, which doesn't work. So I still need to have that x cannot be -2 in my final domain restriction for my solution. All right, so go ahead and pause the video and work on 21 through 23, see what you can do there. It's going to bring up the idea of a U substitution. This is a thing you did a little bit last year, but we're going to harp on it a whole lot more here. So, okay, so now that you've done that, we're going to go through these. So on this first one, 21, what we would want to do is just like we did on that last one, we're going to be multiplying to get rid of these fractions. So my common denominator of all of these is going to be 3x to the second. So I'm going to actually do this first one. I have 4 over x minus 5 over 3x squared all over 8 over x squared plus 6. Okay, so let me pull up my document camera. Okay, so my common denominator here is 3x to the second. So that's what I'm going to be multiplying everything by. So multiply this by 3x squared over 3x squared. There's my giant one. Again, you don't have to draw out the big giant one if you don't want to. It's just kind of a harkening back to when you first kind of learn how to do these. So this times both of these, well, it'll cancel out with that. That's pretty easy. Over here, it'll cancel out one of the x's, so then I'll have 3x times 4, which is going to be 12x. So that's now 12x minus 5 is my new top. And here on the bottom, the 3x times the 8 over x squared, the x squareds are going to cancel out. So I just have 8 times 3, which is going to be a 24. And then this times 6 is nothing to cancel, so it's just going to be plus 18x squared. Now I can do a little bit of reducing here, and I can factor out a 6 from the bottom here, and I can get 6 times 4 plus 3x squared, right? I can do that, but there's not really a major benefit in me doing so because nothing is going to cancel out, but it's still a good habit to kind of be in, to kind of reduce things and make them look a little bit prettier for us. Okay, on B, my trick there is take those negative exponents and write them as fractions, and then do the exact same thing. So B here would end up looking like 1 over x plus 8 over x plus 1 over y to the second. So then your common denominator would be x times y squared, so you're going to be multiplying everything by that. All right, 22. Use substitution. So it's been a while since we've done these, but here we go. If this problem here, 9x to the 6th plus 3x to the 3rd minus 2, well, if I make, well, that's harder to do, but if I say, let's introduce our own new variable, we're going to call it u, right? And I'm going to define u as being x to the third. If I do that, then I get 9u to the second plus 3u minus 2. Now that's a quadratic which I know how to solve. So I could then factor and solve that. Once I have the solution, then I can plug back in x to the third and then solve for x specifically. Right. Then on number 23, we're actually going to try those out. So on this first one, we got 5 times cosine of u squared minus 9 times cosine minus 2. Here we'd say, well, let's make our u the cosine of x. So then I would have 5x squared minus, 5u squared minus 9u minus 2. There we go. On B, I could say, well, let's make u 4x minus 1. So then I would get u squared plus 12u plus 20, right? On C, well, I could make u 7 raised to the x power. So then I would have u squared plus 4u minus 12. Then on D, if I make u x to the 4 thirds, then I would get 4u squared plus 11u plus 6. Now that D is probably the most tricky one here because this 8 thirds is a little bit harder to see as x to the 4 thirds squared. But a little trick to kind of do is look at that middle term. They're typically going to have that be what your u needs to be in order to make it a nice quadratic for us. Okay, so let's do one of these. Let's do solutions, then factor. Okay, so then it just wants us to factor it. The right final terms answer in terms of x. Okay, so I'm not going to do the actual solving yet because we're going to do a bunch of that on the very next set, but you can just get all those to be factored. Okay, so, oops, wrong scene here. Where's my cursor? There it is. Okay, sorry. All right, so let's take a look at 24 through 26. So this is where we're actually going to be trying to solve one of these out. So 24, we have, let's write it out, we have 2 times the sine squared of theta plus the sine of theta minus 1 equals 0. Okay, so I'm going to go, so you can pause and try these out. I'm going to work through all of these just so that we can kind of see both 24 and 25. All right, so hopping down here, I'm going to let my u be the sine of theta. Okay, so that means that I now have 2u squared plus u minus 1 equals 0. So I now want to solve this by factoring, right? So I could say, well, if I do my little x, this is a negative 2 and a 1. What multiplies by negative 2 adds to be 1. It's going to be 2 and negative 1. So then if I do my box, this is 2u squared. This is negative 1. This is going to be 2u negative 1u. So that becomes 2u negative 1 u 1. So that factors into 2u minus 1 and u plus 1. So then to solve for that u, so each of these equal to 0, and I get u is equal to 1/2 and negative 1. So, but I don't care what u is, I care what x is, or in this case theta. So I'd say, well then sine of theta equals 1/2 and sine of theta equals negative 1. And that's as far as they were asking you to get it in those last 3 problems. So that's why I kind of just want to kind of go down to one where we're actually going to take it all the way. Okay. So now that we are here, I say, well, sine of theta is 1/2. Well, what does that mean? Well, unit circle. Make sure you have one of these for the umpteenth time. So I'm saying, hey, where is my sine of 1/2? Well, that happens at pi over 6, at 5 pi over 6. So there's 2 places in which I get that. So pi over 6 and 5 pi over 6. I've already gotten those for what theta can be. But then also sine could be a -1. Well, where is sine of -1? Well, sine is -1 at pi. And that's the only place it is on that unit circle. So it also could be pi. So those are my 3 solutions for that particular problem. Now when we have sines and cosines, we often get more than just the normal 2 because, again, we have those multiple options. All right, so then we hop back over here. Now on number 25. Okay, so this is the one where if you tried this out, you said, well, I'm going to make my u m squared plus 3m minus 1, and then you get u plus rad of u minus 6 is equal to 0. And you said, well, that looks nicer, but I don't know what to do. And that's fine, because the problem is you need to actually make your u the square root of m squared plus 3m minus 1. What that causes to have happen is this becomes u to the second plus u minus 6 equals 0. And then it's a lot easier to actually solve out. So let's go ahead and do that. Okay, so over here, if I'm going to change the m just to be in x's because it's a lot easier than writing capital M's for some reason. We have x squared plus 3x minus 1 plus square root of x squared plus 3x minus 1 minus 6 equals 0. So I'm going to let my u be the square root of x squared plus 3x minus 1. Now that makes this u very obviously, but this here is just this to the second power. So then this becomes a u squared. So I get u squared plus u minus 6 equals 0. So this is why u subs are so nice, right? This by itself, if I just try to say, well, I'll get that by itself and then square both sides, you get some nasty, nasty stuff. But this is pretty darn easy for us to solve. Multiply to be -6, add to be 1 is going to be 3 and -2. So positive 3, -2, u and u. So then my u is equal to -3 and positive 2. Not too bad. So now I just got to set that equal to this. So the square root of x squared plus 3x minus 1 equals -3, and the square root of x squared plus 3x minus 1 is equal to 2. So how do I solve these? Well, to get rid of that square root, I want to square both sides, which isn't that big of a deal now because I just have a single number on this side, which I can square very, very easily. So I get x squared plus 3x minus 1 equals 9, and x squared plus 3x minus 1 equals 4. I'm going to kind of be solving these out at the same time because I'm doing the exact same steps effectively. Subtract over that 9, and I get x squared plus 3x minus 10 equals 0. Here I get x squared plus 3x. I subtracted over the 4, so I get minus 5 equals 0. All right, so then to factor these to solve them, I need, well, what multiplies to be -10, adds to be 3, well, that's to be 5 and -2, so x plus 5, x minus 2. Over here, I need to multiply to be 5, -5, add to be a positive 3. That one, I believe, is not going to factor for me. Let me just double check that one real quick. Okay, so we're going to need to actually do quadratic formula on that one. So then here we get x equals -5 and 2. And then over here, we're going to want to do quadratic formula on it. So that's going to be x is equal to -3 plus or minus big square root 9 minus 4 times 1 times -5 all over 2. So that becomes 9 plus 20 or 29. So I get x is equal to -3 plus or minus rad 29 over 2 as my other solutions for it. Okay. All right. So with that, the only thing that I need to keep an eye out for is that what m cannot be. So looking back at my original here, I can't have any values which cause the interiors to be negative. If I do that, so that'd be 25. It all works out. Okay, so we're good. It probably wouldn't give you one of those here, but you need to check and make sure that none of these answers would cause the A original to give you an A imaginary solution here, but they don't. So which makes sense because they typically wouldn't give us one of those. All right, and then if we go on, here are some notes on operations. Here it's just kind of one of those giant ones, kind of a review of what we did the last time in 3.1.1. Then to kind of close off here, why do we do these substitutions, right? So the big reason is it takes things that are really nasty and ugly, makes it simple and pretty. We do the hard part, which is the factoring, while it's simple and pretty, and then we can go back to that more complex stuff. Even that last one we just did, it's a nasty problem, right? Took a lot of time. We had to factor twice and do the quadratic formula once to get all of our solutions. That is still drastically easier than if I try and do it just the purely algebraic way without ever doing those U substitutions. Okay, so U subs are never things you have to do, but they're things you want to do because it makes things a lot easier. Right? So there's our kind of big rationale there. All right, with that, here is our homework for 3.1.2. We're doing 28 through 35, and I will talk to you guys next time.